All right, the quiz. It's now too late to turn in the quiz, as you know, so that means I can go over it. Okay, so average rate of change. So first I need the y coordinate. So I plug in 2. 2 squared is 4, so 2 comma 4. Plug in 4, you get 16, 4 comma 16. So the average rate of change is just the slope. So 16 minus 4 divided by 4 minus 2 comes out to be 6. In number 2, you were told not to use shortcuts, so I could not accept it if you went straight to a shortcut. You had to use a limit definition that we talked about in the book. Limit is h approaches 0 of f of x plus h, that's x plus h squared, minus f of x squared, all over h. Okay, this comes out to be x squared plus 2xh plus h squared minus x squared, all over h. X squared cancels out. Factor out an h from the top. So limit is h approaches 0, h parentheses 2x plus h divided by h. Cancel the h's. Now you can directly plug in limit is h approaches 0 of 2x plus h. Put a 0 right there and get 2x. Okay, which of course is what you would get by the shortcut, but you were not supposed to do only the shortcut. You could use the shortcut to double check your answer. So before you start, right, you could say, okay, I'm expecting the answer to be 2x now that I know the shortcut, but you were supposed to do the long cut for problem number 2. 3, you can do the shortcut, so that was very easy. 3 times 2 is 6. Subtract 1, so 6x. Derivative of negative 5x is negative 5. The derivative of 6 is 0, so just 6x minus 5. And that's about it. Okay, so that's it for the quiz. All right. Okay, so we are on to 9.5.
Excuse me, did you do number?
Sorry?
Did you do number 3?
Yeah, 6x minus 5. Sure. 6x minus 5. That was usually okay. Most people didn't have any trouble with that. The most problems for people was question 2, as you might guess. So 6x minus 5 plus nothing, 6x minus 5.
When it comes to the y, do you always need that parentheses?
Do I need the parentheses? I'm not sure what you mean. You mean here?
On the 3, number 3 on the y?
I don't see any parentheses there. I'm not sure what you're talking about.
Number 3? For the answer, number 3 is y apostrophe equals. Do you always need that apostrophe?
Oh, y prime, yes. It belongs there for the derivative. That's our symbol for derivative. Y prime
thank you.
equals 6x minus 5. Okay, so we're doing 9.5, which is the product and quotient rule. And just looking ahead, we're going on with one section a day. So here we are, 9.5, Thursday, 9/6. And then you can tell we're getting to the second half of the course when I switch to this part of the paper. So next Tuesday, 9/7, Thursday, 22nd, 9/9. So our next exam is on the 27th. Okay, so that looks like it's what, 2 weeks from today? Right. And you know the way the game works. So you turn in all of this for homework, right? Everything from here to here. It's our longest chapter. Okay, most of it is on the derivative shortcuts and so forth. Okay, so that looks like that's what we're aiming for. Okay, so 9.5 today, we have something called the product and quotient rule. Okay, what's product in mathematics? Product is the answer to a multiplication problem. Quotient is the answer to a division problem. Okay, so we have a product rule and a quotient rule. Okay, so let me show that to you. Here are the problems. As usual, I will try to do as many evens as possible in my demonstration. Okay. All right. So 9.5, which starts on page 583 for me. Product rule, quotient rule. Now, unfortunately, the product and quotient rules are not as easy as you might think. Okay. Now, for sum and difference, okay, if you have something plus something, you just differentiate the first, differentiate the second, add them up. If you have something minus something, same thing. Then just take the derivative of the first minus the derivative of the second. It's not that easy for the product rule. Okay, so in other words, if you say, well, if I have something times something, can I just take the derivative of the first times the derivative of the second? The answer is no, it doesn't work that way. Likewise, for a quotient, if I have something divided by something, can I just take the derivative of the top divided by the derivative of the bottom? No, it doesn't work that way. Okay, so how does it work? So I'll just state it without proof. We won't prove it in this course. It is provable. If you take a calculus course, they might prove it to you. Okay, so on page 584, here is the product rule. Okay, if you want to put it on your cheat sheet, you may. If f of x is equal to u of x, v of x, it's a product. Okay, so here's the rule. U of x, v prime of x, plus v of x, u prime of x. Okay, if you want it shorter, just eliminate all the x's. You write u v prime plus v u prime. Okay. So in words, you copy the first function and you multiply it by the derivative of the second function, and then plus the other way around. The second function times the derivative of the first. In fact, you'll hear me say that over and over and over again. Okay. So if you want to put this on your cheat sheet again, you may. U v prime plus v u prime. Okay. You can put the x's if you want, but I think it's a lot shorter if you just write it like this. Okay, so I'm just going to write that. U v prime is u v prime plus v u prime. In words, just copy the first function times the derivative of the second, plus switch it around. Copy the second function times the derivative of the first. Okay, so this is called a product rule. That's how you differentiate when you have something times something. Okay. Now, a lot of the problems in the homework, once you do the product rule, you get some pretty messy thing to multiply out. Depending on how easy it is to keep going, I might just say stop. But if it's fairly easy to multiply it out, then I'll have you multiply it out. Okay, but some of them are really bad. So if they're really bad, and this is not an algebra course per se, so once you have the product, then we'll just stop. Okay. So we're going to do a whole bunch of products. Then I'll show you the quotient rule. What happens if you have something divided by something? There's a separate rule for that. Okay, so I'm going to try to show you as many evens from this as possible. So what do we have? 1 to 26, 39, 43. Okay, so I'll do a lot of evens. By the way, I never promise I'll do all the evens, but I'll do many of the evens. Okay, and then all the odd answers, you have the answers in the back of the book. Okay, so here we go with the product rule. And then after a while, I'll show you the quotient rule. For those of you that don't have the book and don't plan on getting it, here is the quotient rule. I'll come back to it. It's on the top of 585. Okay. All right, and now the homework problems. So again, for those of you who don't have the book and don't plan on getting it, page 587. Okay, so here's some problems there. You just get it off the video. And then some more on the next page. So 588, here's some. I'm not sure why thing switches to yellow sometimes on me. Okay, so it looks like you can see up to 38-ish. So scrolling down, there's some more. And let's see, some more. Okay, I think that should give you everything there. And this goes up to 43. How high did we have to go in the homework? Just to 43. Okay, so you don't need anything else. Right, so there's all the homework, if anybody wants to get it off the video. Okay. So now the book does products. Okay. And then later it jumps and does some quotients. So I'm going to do a bunch of products first. So I might not be going in order. And the reason why I might not be going in order is I'm going to do a lot of products first, and then I'll come back for the quotients. Okay. And notice this language again. Slope of the tangent line, derivative. Instantaneous rate of change of the function, derivative. Okay, so the answer to A and B are the same. Okay. And what else could it say? It might say the marginal revenue, marginal profit, marginal cost, derivative. Okay. Slope of the tangent line, derivative. Marginal, derivative. Velocity, derivative. Okay. So the answers to A and B here will be the same. Okay, here it says to simplify. Okay, notice these are all products. Something times something, something times something. Here, they're also products, but they made it so messy, right, that they said, don't simplify your answer. Okay? Now you say, what do I do on the exam? Well, if it's too difficult, I'll say you don't have to keep going. But if it's fairly easy, then I should have you simplify it. If you're not sure on a quiz or test, you can always ask me. All right? So here we go. Okay, so 9.5. And again, if my problems do not match yours, you're still learning stuff. Okay, so don't worry about it. Okay, I'm just looking offhand. It looks like a lot of stuff doesn't match, okay, but you're still learning the material, hopefully. Okay, so just casually looking, there's a lot of stuff that doesn't seem to match, unfortunately. But be that as it may. Okay, so y equals 5x plus 3 times x squared minus 2x. Okay, after all, a lot of teachers lecture without giving you any of the problems in the book. So that's what I'm doing overall, okay, so to speak. Okay, first function, second function. All right, so you copy the first function. I call that f. And then it's times the derivative of the second function. So I differentiate x squared minus 2x. That comes out to be 2x minus 2. F g prime. Okay, plus second function, g, x squared minus 2x. And then times the derivative of the first function, which is 5. Okay, so one more time, you copy the first function times the derivative of the second function, f g prime, that's f, that's g, plus g f prime. Copy the second function times the derivative of the first. Okay, now it's just some algebra, tedious. So I FOIL this out. 10x squared minus 10x plus 6x minus 6. First, outer, inner, last is all that. And then distribute the 5. So 5x squared minus 10x. Combine like terms. So 10x squared plus 5x squared is 15x squared. And then that, and that. Negative 10x plus 6x minus 10x is a minus 14x. And then we have minus 6. Okay. All right, number 4. This is the first function. This is the second function. Okay, copy the first function, x to the 12th plus 3x to the 4th plus 4, times the derivative of the second. So the derivative of the second function is 6x squared, plus second function, 2x cubed minus 1, times the derivative of the first. So the derivative of the first function is 12x to the 11th plus 12x cubed. And I'll just say et cetera. That means after that, just multiply it out. Okay. And I think what I'm going to do, yeah, I'm noticing these problems don't seem to match. So I'm going to go ahead and change the assignment. I'm giving you the problems that were supposed to be evens so that you wouldn't have to look them up in the back of the book. But I'm doing problems that are not in the book anyway, right? So I'm going to change it to only doing the odds. Okay. So 9.5, let's make it only doing the odd problems. Okay. 39 and 43 are already odd. So where it says 1 to 26, originally I meant all of them. Okay. I'm only going to show you odds. So the ones I was going to do were evens, and you didn't have the answers anyway. So if I show you my stuff and it doesn't match what you have in the book, it's like not having the back of the book anyway. Right? The main thing is you're learning the material. Okay. So once again, 9.5, let's change it to 1 to 26 odd. And 39 and 43. Okay, this is to make up for the evens, which was in the previous edition, I guess, and they don't seem to match. Okay, mine number 6, which again doesn't seem to match yours, or sometimes it matches, sometimes it doesn't. This number 6 maybe does match. Yeah, it looks like it matches, but whether it matches or not, we don't care. We're just learning how to do the stuff. Okay, first function, second function. Okay, so how do I do it? All right, so you copy the first function, 9x to the 9th minus 7x to the 7th minus 6x, and then times the derivative of the second function. So the derivative of the second function is 15x to the 4th minus 16x cubed plus 9x squared. Remember, the derivative of negative 8 is 0. Plus second function, copy the second function, 3x to the 5th minus 4x to the 4th plus 3x cubed minus 8 times the derivative of the first function. So what's the derivative of this? 81x to the 8th, 9 times 9 is 81, minus 7 times 7, 49, x to the 6th, minus 6. And just stop. So that's it. Okay, so this is the product rule we're learning now. Okay, number 8. And it looks like my 8's not the same as your 8. X squared plus x plus 1, cube root of x minus 2 radical x plus 5. Okay, so this one's already nice, but in order for me to differentiate, and you say, what does differentiate mean? Take a derivative. Okay, I want to take a derivative. I need to write this as fractional exponents. So cube root of x means x to the 1/3 power minus 2 x to the 1/2 plus 5. Okay, so now this is my first function. This is my second function. All right, so we're doing this new product rule. Okay. Again. We have u times v, u v prime plus v u prime. In words, first function times the derivative of the second plus second function times the derivative of the first. Right, so this means x to the 1/3 power. Remember, the number on top is the power. I don't see anything, so you assume it's a 1. And the bottom number is the root. This is a cube root. Minus 2. Square root of x means x to the 1/2 power. The power is understood to be a 1. The root is understood to be 2, so 1/2 plus 5. Okay, so first function, second function. All right, here we go. The derivative is you copy the first function. Don't take the derivative of the first function, just copy the first function. X squared plus x plus 1. Then it's times the derivative of the second. The derivative of x to the 1/3. 1/3 comes down. X to the 1/3 minus 1. That's 1/3 minus 3/3, which is negative 2/3. Then the derivative of this, so minus 2 times 1/2 is 1. So if the coefficient is 1, you don't have to write anything. X to the 1/2 minus 1 is negative 1/2. Right, 1/2 minus 2 over 2, negative 1/2. And plus the derivative of 5 is 0, so you don't have to write it. Okay, so all of this right now, all of this was the first function times the derivative of the second. Plus the other way around. Second function. So if I'm going to write the second function, I might as well write the original. So I just copy this. Cube root of x minus 2 radical x plus 5, second function. And now times the derivative of the first function. So the derivative of x squared is 2x. Derivative of x is 1. And the derivative of 1 is 0, so you don't have to write it. Okay, so there it is. And according to the directions, just stop. Don't try to multiply that out. That's crazy. It's going to be real bad. So we'll just leave it alone. Okay, then number 10. And let me just check to see if that 10 is the same as your 10. Looks like number 10 is, well, maybe it's not the same as yours. Now I can't tell. All right, so just go with it.
It is the same, Professor.
It is the same. Oh, okay. Have all of these been the same? Or maybe this was the same in the book that I gave you before. Okay, so whatever. Okay, so this time they give you a point, and all those words, right, means derivative. So what do they say? Like slope of the tangent line, instantaneous rate of change, derivative, right? And what else might they say? Velocity, marginal, derivative. Okay, first function, second function. So y prime, first function, copy it, x cubed minus 3, times the derivative of the second. So what's the derivative of this? 2x minus 4. Plus the other way around. Copy the second function and multiply by the derivative of the first, 3x squared. Okay, now what's going on with all this and the crossing out? Okay, now I'm plugging in 2. So plug in 2 here, 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 and here. So 2 cubed, 2 times 2 minus 4. And why am I crossing this out? I notice right here I have 2 times 2, 4, minus 4, 0. And 0 times that is 0. So all of this is 0. So I only have to worry about this thing here. Unfortunately, this is not 0. So let's see, plug in 2, 2 squared minus 4 times 2 plus 1 times 3 times 2 squared. Okay, clean that up, that's 4 minus 8 plus 1, and that's 3 times 4. So 4 minus 8 plus 1 is negative 3. Negative 3 times 4 comes out to be negative 36. That's my slope. So the answer to A and B are both negative 36 now. Okay. All right, so that's the way the product rule works. Now, I'm going to jump all the way to 24 because that's another product. So 24, write the equation of the tangent line to the graph of the function at the indicated point. Okay, we played that game before. Find the derivative, throw it into the point slope form. And check the reasonableness by graphing. Okay, forget about that. I'm not requiring you to have a graphing calculator. Okay, so y equals blah, 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 blah at x equals 0. And I notice that is the same as what I have here. So I'm jumping to 24. So what happened to all the in-between ones? They're quotient rule. So after I do 24, then I'll show you the quotient rule. What happens when you have something divided by something? All right, so y is 4x squared. Oh, let me check that. Yeah, 4x squared plus 4x plus 1 times 7 minus 2x, x equals 2. Okay, notice they don't give me the y value. So I have to figure out the y value. Plug it in. Put 2 here, here, and here. So 4 times 2 squared plus 4 times 2 plus 1. 7 minus 2 times 2. So let's see, that's 7 minus 4, which is 3. So that's the easy part. Okay, this one's going to be what? 4 times 4, 16. 4 times 2 is 8 plus 1. Okay, 16 plus 8 is 24, plus 1 is 25. So 25 times 3, 75. So the ordered pair, x1, y1, is 2, 75. That's my point. I need the slope, then I'll throw it into the point slope form. Okay, so automatically I know I have a x minus 2, y minus 75. The only thing I need is the slope. So slope means derivative. Okay. So here we go with the product rule again. Copy the first function, 4x squared plus 4x plus 1, then times the derivative of the second function. The derivative of 7 is 0. Derivative of negative 2x is negative 2. So there's negative 2. Plus, second function, 7 minus 2x, times the derivative of the first function. So what's the derivative of this? That's going to be 8x plus 4. Okay, now I plug in 2. So that's the derivative anywhere, slope anywhere. I want it particularly at 2. So now I plug in 2 right there, 2 right there, 2 right there, and 2 right there, and grind it out. Okay, so we say y prime of 2, right? So 4 times 2 squared plus 4 times 2 plus 1 times negative 2. 7 minus 2 times 2, we just did that. 8 times 2 plus 4. Okay, so a lot of computation here now. So now what do we have? 4 times 4, 16, plus 8, plus 1, which is 25. We just did that, right? Times negative 2. And this is 7 minus 4, which is 3. 8 times 2 is 16. 16 plus 4 is 20. Okay, so what do we have is 25 times negative 2, negative 50. Plus 3 times 20 is 60. Comes out to be 10. That's my slope. Derivative means slope of the tangent line. Okay, so point, slope. Y minus y1, y minus 75 equals m, 10, parentheses, x minus 2. And again, you can stop right there. Okay, that was the product rule. Put it on your cheat sheet. Now we have the quotient rule, which is unfortunately not as nice. Again, we won't prove it. We'll just state it without proof, but it is provable. Okay, page 585. Quotient rule. F of x is u of x over v of x. It definitely looks worse. So f prime of x is v of x, u prime of x, minus the other way around, u of x times v prime of x, all over v of x squared. Okay, put it on your cheat sheet. Some of it is like the product rule. Okay, the top is very much like the product rule. You have one function times the derivative of the other, and then you switch it. Right? So see how it's one function times the derivative of the other, then you switch it, the other function times the derivative of the other. One big difference is that for the quotient root, there's a minus. The product root, there was a plus. And the other thing about the quotient root, you're dividing by v of x squared, the denominator squared. Okay? So I'll say it in words. I'm not going to write it. It's already here. It's too much to write, but I'll be saying it a lot. You take the bottom times the derivative of the top minus the other way around. Top times the derivative of the bottom. So again, it's the idea if you have one function times the derivative of the other, then switch it. All over the denominator squared. You square the denominator. Okay. Using numerator and denominator, you take the denominator times the derivative of the numerator minus the other way around, numerator times the derivative of the denominator, all over the denominator squared. Okay, and again, it's a question, do I need to clean up the numerator? Normally, you wouldn't clean up the denominator. Just leave it as blah, blah, blah squared. The numerator, though, sometimes comes out nice. Okay, so if it's quote unquote easy enough, you should keep going. But if it's not easy enough, and I'll show you, then don't do it. I'll say one other word. See, there's a v of x here and a v of x squared here. That is always going to match that. So you might say, can I cancel these out? And the answer is no. You might recall from algebra. Okay, once you have an addition or subtraction, you cannot cancel here. Now, if you don't have that minus sign, or pretend this happened to come out to be 0, right? If this comes out to be 0, then you would have this. Now you can cancel one of the v of x's with the v of x's. But as soon as you add or subtract something, then no, you're not allowed to do that. Okay, so this is the quotient rule. Again, it's on page 585. Put it on your cheat sheet if you wish. Okay. Again, if we were meeting face-to-face, I would probably make you memorize it. So you should be happy in some sense. You're taking me this semester during the pandemic. That I'm not making you guys do that. Okay, so quotient rule means there's a division, right? So how do you differentiate that, or that, or that, or that, and so on, right? So here we go with that. Okay, so number 12. C of x, and quite often C will stand for cost later on. So 2x cubed over 3x to the fourth plus 2. And let me see, yes, that is the same in my book as yours. But anyway. Okay, so here's this new quotient rule now. So you take the denominator, copy it, times the derivative of the numerator. So what's the derivative of 2x cubed? 6x squared. Minus, now watch out, for the quotient rule, it's a minus. For the product rule, it was always a plus, right? Plus. 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 But for quotient rule, it's a minus. Then you switch them. You switch them. Top, 2x cubed, times the derivative of the bottom. So the derivative of the bottom is 12x cubed. Remember, the derivative of 2 is 0, so you don't have to write anything after that. All over the square of the denominator, so 3x to the fourth plus 2 quantities squared. Okay, now, usually you don't want to multiply out the bottom. Just leave it alone. The other thing I noticed is, notice what I said, that this matches this, 3x to the fourth plus 2. But can I cancel these out? No, because you're subtracting something. If this expression over here came out to be 0, right? If this was all 0, forget about it. Then you can cancel. But once you add or subtract something, no. And then question arises, suppose I give you something like this on the exam. Say, should I multiply it out? This is not that bad to multiply out. And besides, you get a cancellation. Okay, so you should multiply this one out. So that times that comes out to be 18x to the 6th plus 12x squared. That comes out to be negative 24x to the 6th. Okay, and yes, indeed, it looks like I combined these two. So 18 minus 24, negative 6x to the 6th plus 12x squared over all over 3x to the fourth plus 2 squared. And you can stop there. Normally, it's not to your advantage to multiply out the denominator, so just leave it alone. Okay, so this is the quotient rule. Okay, take the bottom times the derivative of the top minus the other way around. Copy the top times the derivative of the bottom. That whole thing divided by the square of the denominator, square of the bottom. It's clearly harder. Okay, 14. S is equal to this mess, t cubed minus 4 over t cubed minus 2t squared minus t minus 5. And is that the same in my book? Yes, this one seems to be the same in my book. So maybe I should have said do the evens anyway, but it doesn't matter because you know, you didn't have the answers in the back of the book anyway. So I'm going to end up doing almost all the evens that were going to be there. So it turns out to be pretty much the same thing. Okay, copy the denominator, t cubed minus 2t squared minus t minus 5, times the derivative of the numerator. So what's the derivative of this? 3t squared. Minus the other way around. Copy the numerator, t cubed minus 4, and then times the derivative of the denominator. Okay, so let's differentiate the denominator. Again, differentiate means take the derivative. So 3t squared, right? Minus 4t minus 1. And you say, what about the negative 5? What's the derivative of negative 5? 0, so you don't have to write it. All over the denominator squared. T cubed minus 2t squared minus t minus 5 squared. Okay, and for this one, do we feel like multiplying it out? No, we don't feel like multiplying all that stuff out. So we'll stop. Okay, I mean, it's a lot of heavy-duty algebra. Officially, this is not an algebra course. This is math analysis for business, so we'll stop there. Okay, normally you would never multiply out the denominator. And notice again, that matches that. But can I cancel? No, because there's a minus sign there. So you're never going to be able to cancel right here. Unless this thing happened to come out to be 0, but that almost never happens from experience. Okay, 16. changing the problem just a little bit. Y equals 200x minus 100x over 3x plus 1. Okay, this one's easy. The derivative of that is 200, right? So how do I do this? I'm going to change it so that there's a plus, and I apply the negative to the top, let's say. So let me show you how I did that. It was originally a minus. I made that a plus, and this is a minus. So I don't have to worry about the negative that's in front of the whole thing. Okay. So I'm going to assume the numerator is negative 100x. Okay. Denominator is 3x plus 1. Okay, so dy dx. You say, what is dy dx? Derivative. Notice here I put ds dt because the variables are s and t. It still means derivative. Okay, so the derivative of this is just 200. That's the easy part. So the harder part is this one. So how do I differentiate this quotient? Okay, and so what does differentiate mean? Take a derivative. All right, so here we go. Bottom times the derivative of the top. So what's the derivative of negative 100x? Negative 100. Minus, okay. This is supposed to be a minus. Okay, so pretend temporarily it's a minus. The numerator, negative 100x, times the derivative of the denominator, which is 3. So it's minus, minus, but you know what I do when there's two minuses, I like to make them a plus, and you should do likewise. So originally it was minus, minus, right? The formula has a minus. There's another minus from a negative 100x. So two negatives make a positive. So it's going to be plus. All over 3x plus 1 squared. Okay, this looks easy enough to clean up. That comes out to be negative 300x minus 100 plus 300x. Okay. Well, very conveniently, these guys cancel out. So I just have 200 minus 100 over 3x plus 1 squared. Final answer. Okay, so that's that one.
Professor,
Yes, question.
why did we change the sign?
Why did I change the sign here?
No, in the original function.
Right here? Yeah, it was easier for me to explain it if instead of minus right here, change it to a plus and then apply the negative there. Okay, otherwise you'd have to worry about that, carrying that negative around all the way through. Okay, so I thought it'd be easier for teaching purposes to make this a plus and put the negative over here. Okay, technically you don't have to do that, but you'd have to remember to put that negative throughout the problem. Okay, you'll get the same answer. Okay, so that is that one. Next one is 18, which is not very nice. Find dy dx for y equals this funny thing. 2 radical x minus 1 divided by 1 minus 4 times the cube root of x cubed. Okay, so I can tell right away that's going to be quite messy. All right, so before I start, I'm going to change that to x to the 1/2. Change this to x to the 3 over 2. There's an understood 2, it means square root. So power over root, right? Power over root. Okay, so dy dx, the denominator, 1 minus 4x and 3/2, times the derivative of the numerator. So what's the derivative of this? 1/2 times 2 is 1. So the coefficient is 1, which means you don't have to write it. And then x to the 1/2 minus 1 is negative 1/2. Okay, so that's the bottom times the derivative of the top. Minus the other way around. Top, just copy it, times the derivative of the bottom. So what's the derivative of the bottom? The derivative of 1 is 0. Let's see. Negative 4 times 3/2 comes out to be negative 6. X to the 3/2 minus 1 is 1/2. All over 1 minus 4x and 3/2 squared. And this one's so bad, we'll just stop there. Yeah, we'll just leave that alone. Okay, 22. Recurring theme. Find the slope of the tangent line and an instantaneous rate of change of the function. It means derivative. Okay, so the answer is going to be the same for A and B. So once I figure it out, the answer for A, B is going to be identical. Instantaneous rate of change, slope of the tangent line, same thing. Okay, so y equals x squared minus 4x over x squared plus 2x. So here we go. Y prime is bottom times the derivative of the top. So what's the derivative of the top? 2x minus 4. Minus the other way around. Top times the derivative of the bottom. 2x plus 2. All over the square of the denominator. X squared plus 2x, quantity squared. All this junk here is derivative. And now I plug in x equals 2. See, what about the negative a half? Don't worry about it. The negative a half is for y. There's no y's anywhere in my expression, so I only plug in 2 for x. Okay, so 2 there, 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 and there. 2 squared plus 2 times 2. Every time you see x, 2. 2 times 2 minus 4. And notice very conveniently, again, this is 0. Very kind of them. 2 times 2 is 4. 4 minus 4 is 0. 0 times that is 0. So that's all nothing. Okay, minus 2 squared minus 4 times 2, parentheses, 2 times 2 plus 2, all over 2 squared plus 2 times 2. And that comes out to be 4 plus 4. So the bottom is going to be 8 squared. So what do I have on top? A negative 4 minus 8. 4 minus 8 is negative 4. 2 times 2 plus 2. 4 plus 2 is 6. Okay. Double negative, 2 negatives make a positive. So 4 times 6, which is 24. 24 over 64 comes out to be 3/8. Okay. And yes, that means the answer to both A and B are 3/8, as we said before. Same answer for both of them. Okay. Okay, then let's see, 26. Y equals blah, 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 at x equals 2. Write the equation of the tangent line. All right, so same business. We know what to do. Find the slope. Plug in a y minus y1 equals m times x minus x1. And skip all the graphing stuff. So stop at the point and forget about check, whatever. Okay. All right, so here's the function, and we're at x equals 2. Okay, now again, they do not give me the y value, so I have to figure out the y value. So I plug in 2. 2 squared minus 4 times 2 over 2 times 2 minus 2 cubed. That comes out to be 4 minus 8 divided by 4 minus 8. Anything divided by itself is 1. So I have 2 comma 1. All right, so now I find the derivative. So bottom, okay, ignore all the crossouts temporarily. 2x minus x cubed times the derivative of the top, 2x minus 4, minus the other way around, x squared minus 4x, times the derivative of the bottom, 2 minus 3x squared. All over the denominator squared, 2x minus x cubed squared. Okay, so that's the derivative anywhere. Now I want the derivative at x equals 2. So now I plug in 2 everywhere. Put a 2 there, 2 there, there. So that's what all these 2's here in red are. Put a 2 there, 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 and there. Okay. And once again, I get a nice cancellation here. If you plug in 2 here, 2 times 2 is 4. 4 minus 4 is 0. 0 times that is 0, so that's all gone. Minus 2 squared is 4. Minus 4 times 2 is 8. 2 minus, all right, 2 squared is 4. 3 times 4 is 12. All over 2 times 2 is 4. Minus 2 cubed is 8 squared. Get some pretty messy algebra here. So there's a negative times negative 4 times negative 10. So negative, negative, negative. I can change these two negatives to positive, but I still have a negative 10. Okay, so 4 times negative 10 is negative 40. The bottom, negative 4 squared, 16. This reduces to negative 5 halves. Point, slope, point slope form. Y minus y1 equals m, negative 5 halves, times x minus 2. And there we go. Okay. All right, then let's see. That takes care of that. 26. And all I have left is talk about the other problems. So 39 and 43. I wasn't going to actually do them, but I'll just talk about them and tell you what's involved. So I'll be done in a few minutes. Okay, so in a few minutes. So if you have any questions, I know some of you put something in the chat, but I can't see the chat right now. So sorry about that. So if you have any questions, in a few minutes I'll be done. And then I'll check the chat, or you can unmute yourselves for any other questions. Otherwise, that's about it. And it's about, what, 6:30-ish right now? Something like that. Okay, so what about 39 and 43? Well, I guess the first thing I have to ask is to see if this is the same question as yours. 39. Okay, CFP is 8100P divided by 100 minus P. Is that the same as what you have? Anybody?
The same.
Same, good. Okay, so cost benefit, costs in dollars of removing P% is given by this formula, 8100P over 100P. Find the rate of change of C with respect to P. Okay, that means take the derivative. Okay, and you should have the answer in the back of the book. So it looks like it's going to be a quotient root, right? So just do the quotient root for 39. So it is a word problem, but ultimately you're just doing a quotient root. All right, so that's that. And what was the other one? 43, where's 43? Yeah, so 43 and I'm done. And then I'll take any questions you might have. Let me see if 43 matches your 43. A revenue function. Okay, blah, 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 blah. The main thing is this is the revenue function. 25 plus x, 300 minus 10x. Is that the same thing?
The same.
Even? Okay, it's the same. Good. All right, so find the marginal revenue. Aha, derivative. Right? Okay, and here's the other tricky thing. X is the additional people after 25. Okay, it says right here, where X is the number of additional people above 25. So if the group contains 30 people, I'm assuming it says the same thing there. Does it say the same thing for you guys? This stuff here?
Yes.
It does? Okay. So you don't plug in 30. X is the number above 25. So how much above 25 is 30? 5. Okay. So you're going to plug in 5, not 30. All right. So what do you do here? Take the derivative. You are going to use the product root. Okay. And then once you get the product rule, you plug in 5, not 30. Okay. All right, so that is that. Okay, so I'm done with my formal lecture. Let me stop the share, check the chat. Let's see. Okay, if you just came late, yeah, please send me an email for that. If you submitted a quiz, I won't get a chance to get to it until much later tonight. Sorry. Okay, attendance. Yes, so we're only doing the odds now. From there. Okay, so 9.4, number 53C. Somebody asked for that. Okay. So let me see what that was. (9.453C). Okay, so I have to get some paper here. Share the screen again. Okay, 9.453. This is on page what? 581. Okay, C of x is equal to 4,000 plus 55x plus 0.1x squared. Cost function. Okay, so let me write that down. I'm sorry, I can't show you the book at the same time. C of x is equal to 4,000 plus 55x plus 0.1x squared. Okay. There's also the average cost function where you divide by x. Right? So C bar, we call it 4,000 over x plus 55 plus 0.1x. Okay, hopefully this is the same. Is this the same for you guys? Or okay. If you don't say anything, I'm assuming that it's the same. Others, I'm doing this for no reason, I guess. Green. Good. Find the instantaneous rate of change of cost and find the average cost. Well, yeah, so you pretty much have to do all of it. So A, find the instantaneous rate of change of average cost with respect to the number of units produced at any level of production. So I need the derivative of this. You should think of this as 4,000 x to the negative 1 plus 55 plus 0.1 x. Okay. So instantaneous rate of change of average cost. Okay. So C bar prime is negative 4,000 x to the minus 2 plus 0.1. That is negative 4,000 over x squared plus 0.1. B, find the level of production at which this rate of change equals 0. That means I set this equal to 0. Set that equal to 0. Throw that over there. I know 0.1 is 1/10. I'll change it to 1/10 equals 4,000 divided by x squared. I will cross multiply. X squared equals 40,000 square root. I don't need a plus or minus. These word problems, x is positive, so x is equal to 200. Okay, C, at the value found in part B, find the instantaneous rate of change of cost and find the average cost. Okay, so you have to plug in 200 here. So they say, find the instantaneous rate of change of cost and find the average cost. So C bar of 200. Plug in 200 to C bar of X. That means 200 goes in here. And again, I don't want to take up class time for that. And then it also says you plug in instantaneous rate of change of cost. So that means you plug in 200 to the derivative. Find the instantaneous rate of change of cost. So you plug in 200 to C prime. We never found C prime. C prime was what, 55 plus 0.2x. Okay, and assuming I didn't mess up anywhere, when it says, what do you notice? Okay. I believe the answer is that they came out to be equal. Okay, so the answer to part C should be, they are equal, I believe. Okay. So that's that. Back, double check the chat. Okay, 9.4, number 30. Okay, 9.4, 30. X cubed over 3 minus 3 over x cubed. X equals -1. Write the equation of the tangent line. Okay. Let's see, what else is there in the chat? Okay, so I can't see. And once I switch to showing you the overhead, I can't see the chat anymore. You can still put stuff in, but I won't be able to see it until I get out of that mode. Okay. Yeah, I said this is my 30. Is this the same as what you have? Anybody? No. Okay, if nobody says anything, I'm just going to do it and assume it is. So 1/3 x cubed minus 3x to the -3rd. Okay, first let me plug in 1. So plug in 1, I have 1/3 minus 3 over 1 times 3 times 3. So 1 minus 9 is -8/3. So the ordered pair is -1, comma, -8/3. Now I find the derivative. Three times 1/3 is 1. So I have 1x squared. -3 times -3 is +9. X to the -4th, which is x squared plus 9 over x to the 4th. Now I plug in -1. So -1 squared plus 9 over -1 to the 4th power, which is 1 plus 9 over 1 over 10. That's my slope. Okay, point, slope. Y minus a minus, double negative, equals m times x minus a minus 1, x plus 1. that's that one. Okay, stop the share.
Professor.
Anybody else? Let's see. Okay, I've caught up with the chat, it looks like. Okay, so anybody else with anything, please?
Yes. On the last question you did, the -3 power, when you added -3, why did you
Okay.
put the negative sign in there?
Okay, let me try to get that back again. Sorry, there's no way I can do this fast. There's all, you know, when you share the screen, there's all these buttons that you have to push and stuff. So. Okay, something about the -3 here somewhere?
Yeah,
about
that
over here?
one. Yeah.
Okay, so I made this a coefficient of 1/3. Dividing by 3 is multiplying by 1/3. And that is -3x to the -3rd power. In order for me to do the power root, that x to the -3 has to go upstairs. It can't be in the denominator, so I write it like that. Then I can use the root. So the derivative becomes 3 times 1/3 is 1, which means you don't have to write it, x squared. And then -3 times -3 is 9. X to the -3 minus 1 is -4. And then I went in it from there. Is that okay? Okay. Does anybody else want to ask me a question about this? Maybe just unmute yourselves, because otherwise I have to keep switching back and forth between sharing the screen and not. So does anybody want to unmute yourselves and ask me something about this particular one, please?
It's
No?
-1.
About the -1? Yeah, so I have to plug in the -1 here to find the y value, and also here to find the slope. So -1 gets plugged in here and here to give me the y coordinate, -8/3. You also plug in a -1 there and there to find the derivative. Okay. Right, so let me stop the share there again. And let's see the chat. I think I've caught up with the chat. Okay. Any of you that miss attendance, please send me an email. Of course, I can't do it now when I'm teaching. And anything else like that. Likewise, if you submitted a quiz just recently, I won't get to it until maybe even tomorrow, because I'm teaching all the way until 9:25 in theory. Okay. So again, if you submit the quiz just before class starts, you can do it, but I won't be able to confirm it until maybe the next day. All right, anybody else, please? If not, we're done. Okay, so we're done. Next time, I'll do a section. You'll probably get a quiz on Thursday about product root, quotient root, and maybe the new stuff in the next section, something called the chain root. But again, since you can talk about it, don't really worry about studying or anything like that. So at the end of class next time, there'll be a quiz as usual. Okay, that'll do it for tonight, folks. So have a good evening, and we'll see you next time. Okay, bye,
Good night, everyone.
Thank you.
Bye.
Thank you.
Bye. Have a good night.
Thank you.
Thank you.